Alright, welcome to Geometry Unit 1. This is practice lesson number 1, and we are revisiting Pythagorean's theorem in pretty interesting detail this unit. So let's start off right away, and I'm going to take we're showing these 1, 2, 3, 4, 5, 6 squares, and it gives us the side measures of a right triangle, 6, 8, and 10. And so we're going to make a right triangle with 2 legs of these right triangles being 2 of these measures. If you know anything about a right triangle, that the longest leg of a right triangle is going to be the hypotenuse. So we're not going to be using 10 as the hypotenuse, so the 2 legs are going to be made up of 6 and 8. So I'm going to make WC6. I'm going to use some patty paper to do that, and a straight edge to make sure I'm nice and straight. So I'm going to use here, I'm going to make this 6. I'm going to use this black thing here, this black pen, 6. Okay, that's my 6, and then I'm going to go, and that's going to be WC. WC. So C has to be over here, and this has got to be W, and then WN is going to be 8. WN is going to be 8. Make sure I make that nice and straight. If I mess up the points, I'll just erase them and rename them when I'm all said and done. WN is going to be 8. WN is going to be 8. N is going to be 8. And then the comparison of that is going to be 10. That would be 10. So NC would be 10. So this is 10. This is 6, and this was 8. So that's my right triangle. My right angle there. That's my right. There's my triangle. Okay. So this is the side. This is the triangle, right angle, with WC is 6, WN is 8, and NC is 10. That's my legs and my hypotenuse. Okay. To show visual proof, which side would be placed around WN? Well, I just did that. That's how I made it. WN is my 8. So WN, the 8 by 8 square. 8 by 8 square is my WN. Okay, and then WC is my 6 by 6 square. 6 by 6 square. So that's how you kind of visualize those 2 questions there, right? Another way you could, that's a weird way to ask those questions, right? But you see the C, N and C are the 10 long, is the long 10, right? So you know that C and N have to be the endpoints of the long one. So you know that W and N have to kind of be, W and N have to be like your 8, and W and C have to be your 6. So it's a lot easier if you just visualize it and kind of draw it on paper, right? So kind of hard to visualize in your head. Let's work through that one. Okay, so MTB is shown where MT is the square root of 74. So this is the square root of 74, and MB is 5. Find, we'll call this X, we'll call this Z, right? We're going to find Y. because remember, Pythagorean's theorem is z squared equals x squared plus y squared. Right? I'm going to rearrange the equation to solve for y. Okay, so we'll bring z over there, we'll bring x over here. So it's going to be z squared minus x squared equals y squared. And then we'll just take the square root of both of those, and that's going to equal y. So z squared minus x squared equals y squared. Okay, so what we'll do now is we'll say, okay, well, let's do we could also that's one way to approach it. We could also plug in our values first, because that's could be a little messy. Or we could be like, okay, the square root of 74 squared equals 5 squared plus y squared. That's another way to approach it. Okay, so we can go with that's two different ways to start this and to approach it. So how do we want to do this? So let's pause it and think about the algebra for a second. Okay, so let's go ahead and do our squares here. So 74 squared is, square root of 74 squared is 74. 25 squared is, or 5 squared is 25, and this is going to be equal, this is plus, I'm sorry about that, plus y squared. Nothing's just changed yet, we just did some squaring operations. Okay, and now we're going to just take 25 and we're going to subtract it from both sides. So 74 minus 25 equals 49. 49 equals y squared. Now we're going to take the square root of both sides. Right, so the square root of 49 is 7, and the square root of y squared is y. So y equals 7. So that's how you do that one. Okay. Let's go on to the next one here. I have to hopefully I don't get disconnected moving this thing over. A right triangle has the side lengths. Let's make a right triangle. Let's see, square root of 3 times 6 is like 10.3 something, and 15 is 3. Alright, so 6 square root of 3 is going to be longer. Alright, so we'll say this is 6 square root of 3. Say this is square root of 15. And then this is our hypotenuse. Now I would like to draw drawings. Okay, and we're trying to find z. Okay, so we draw our drawings here. Maybe I tilt it out a little bit so you can see it. Okay, all right, so this one's pretty easy. All right, so it's z squared equals the square root of, let's just do, never mind, let's not do that. Let's do z squared equals square root of 15 squared plus 6 times the square root of 3 squared. Alright, so how am I going to do this one? Well, I'm going to do it like this. Alright, so this is this squared, and this is this squared. Alright, so I'm going to go z squared equals 15 squared is 15, plus, I'm going to work that 6 squared back into there. So 6 squared is 36. That's going to be square root of 36 times 3 is 108. Right? So that's going to be, if I square 108, it's going to be like that. It's going to be like that. Okay, so if you don't know how I did this, so that's going to be the square root of 108 squared, right? Because when I square, so when I take a number out of the radical, I have to, I take its, okay, so this, okay, so this, I put, in order to put 6 back into the radical, so 6 square root of 3, 6 square root of 3. Okay, in order to take 6 out of the radical, I had to break it down. I had to take its root. So its square root. So 6 squared is 36, right? So this would be 36 times 3 in order for me to have taken that out, right? So to put it back into the radical, I have to square it and put it back into the radical, and then so to take, and then I have to multiply it back into the 3 to make it back, and that means it's 108. Okay, so I did all that kind of like one big step. Sorry about that. Right, so then I have so now that I've squared that, now I have z squared equals 15 plus 108. Right, so plus 15 equals this. Equals the square, z squared equals 123. Now if I take the square root of 123, it's 11.1, some really long, ugly number. So let me see if the square root of 123 is, so that's the square root of 123. I don't think 123 is, 123 divided by like 3 is 41, okay? 41, I believe, is a prime number. Let's see here. Yeah, 41 is a prime number. Yeah, so there's no perfect squares inside of that. So the easiest way to do that is z equals 123. Moving on to the next one here. Let me zoom out. Zoom out some over. Oh, that's about as far out as I'm going to zoom. And zoom back in. Okay. Alright, so we have triangle RLX. That's the big one. And LN is parallel, or correction, congruent to or equal to the, that should be a congruent sign. Is congruent to NX. I mean, that's the midpoint. And RL, this entire length, is 8.766. XR, this hypotenuse of this big triangle, is 13.184, and YX is 5.39. Okay. Determine the length of NY. So we got to figure out this NY, this little guy right here. We got to figure out this guy. All right, so we got to do some interesting math here. This should be fun. Right. Interesting. So we're going to figure out this little guy. So we got a bunch of little triangles in here, a bunch of right angles. So first step is recognizing that LX is a right triangle. Okay, and we know that this and this are equal. So this is equal to that. So whatever length we find it here, this and that are the same. And we know this length right here. So we know that once we find this length, we can use Pythagorean's theorem to figure that out. Right, so we use Pythagorean's theorem to figure this one out. Okay, and then we half that, and then we'll have this one. We'll have this one. And once we have this one, we have this one right here, and then we use Pythagorean's theorem to find that one. Okay, so we have, and we don't have to deal with any of those pesky radicals because it's already in decimal form, and we'll just round everything to the nearest thousandths. Right, so we know that we'll call this x squared. Okay, we'll call that x. We'll just call that x. All right, so x is going to be equal to the square root of, we'll call this y, we'll call that z, and we'll call that y. Okay, we'll call this a, we'll call this a, we'll call this b, we'll call this c. But they should be blue. A, B, and we'll call that C. That'll work. Okay, so x is going to be equal to z squared minus y squared because Pythagorean's theorem. Okay, so x equals 13.184 squared minus 8.766 squared, and so x, so I have square root, oops. Alright, so 13 point, that was calculator, use error, 0.84 squared, oh I forgot to put the square root button, that's what I did wrong, minus 8.766 squared equals, take the square root of that, and then so x equals 9.848. Okay, so that's x. Now I'm going to divide that by 2. So I'm going to say that b equals x divided by 2. Equals 4.924. Okay, so this equals 4.924, which makes sense. 4.924. Okay, and then so now we got to figure out that a is going to be equal to the square root of y, I call that c squared minus b squared. I call that b squared. This should be b squared. B squared. Oh, wait a minute. Got my variables mixed up. That was b squared. Here we go, that's right. Okay. That's going to be equal to 5.39. What was it? Square it. Then subtract 4.924 squared. And then take the square root of that, and that'll be equal to 2.19. That's 2.19. Okay, so there you go. That is ny, 2.19 to the nearest thousandths, 2.192. 2.92. Okay, there we go. Now let's go through and find the length of bn. Complete the table right nearest the nearest tenth. Oh, okay, so if these are So given this, find that. And it's just an exercise in squaring stuff. Okay, so Bn is, call it y, Np is x, Bp is z. Okay, so this is going to be 7 squared plus 95 squared equals, take the square root, that's going to be 95. 95.258. Okay, now it's going to be 73 squared minus 48 squared equals, take the square root of that, that's going to be 55. This is going to be the 42 squared minus 5 squared equals, take the square root, 2.060. This is going to be 65 squared, 65 squared minus 33 squared equals, take the square root of that, 6. And this is going to be 29 squared, 29 squared minus 2 squared equals, square root is 28.9. Okay, so if you haven't picked up the patterns, whenever you're finding the hypotenuse, you add the squares, then square root it. If you're finding one of the legs, you do this first, then subtract, square it. Just take this, square it, then take the leg and then subtract the leg and square it, and then you square root the answer to figure it out. Okay, I'm gonna go ahead and pause it, check my answers against the key, make sure everything looks right, and then get back to you. All right, I think I had some calculator button pushing error on these 3, so I'm gonna do these ones again. All right, so I'm gonna do 42 squared. Right, so the square root of 42. This is the square root of 42, right? And then I'm going to square it. Okay, that's what you start with. Then you subtract 5 squared equals, that's 17. You take the square root of that, that's 4.123. 4.123. That's the correct answer. Okay, then you have these two. You have to take 95 squared, that's what I didn't do, and then you square it, right? Then you add 7 squared, right? And that equals, and then you take the square root of that, and that equals 12. I don't know what happened there. Probably didn't do the whole squared thing of the squared. Okay, and this one, this is the square root of 29, is 29. Or 29 squared is 29. 2 squared is 2. All right, so it's going to be 2 plus 29, and then we're going to take the square root of that is 5 point. Wait a minute, that's not what that says. 29 square root squared plus 2 square root squared equals 31. Take the square root of that is 5. That can't get that. No, that's 5.556. I think this thing is wrong. Square root of 27. Where do they get? Oh, I added and didn't subtract. Okay, so it's going to be 29 squared, square root minus 2 squared equals, take the square root of that, 29 minus 2, the square root of that is 5.196. 5.19196. Those are the correct answer to those. Okay, so if you have any questions of that stuff, hope that helps out on 7.1. We can walk. It helps if you show your math. But getting quick with your calculator helps too on the exams. Have a great day.